Hi, this is George Alger. Welcome to today's segment of Our Ventura TV. Today we're going to be speaking about marine sediment and climate change. And joining us is Megan Fung, who is a climate change researcher. Welcome, Megan. And for many of us who are thinking about climate change, at least myself, I don't automatically go to marine sediment. All right, can you sort of draw this connection for us?
Yeah, well, thanks, George, for having me. So I consider myself a paleoclimatologist. Geology is a really vast field. And so what I do is I study ancient climates. And when I talk about ancient, I'm talking about thousands to millions, even hundreds of millions of years ago. And since, of course, it's not possible to go back in time to, see what climate was like 50 million years ago, scientists rely on imprints that are created during climates of the past. And you may have actually heard of some of these before: tree rings, ice cores, corals in the ocean, stalagmites, stalactites, and caves. These are all really great records of ancient climate that extend our understanding of climate weather by thousands to millions of years ago. Um, and so, the reason I've spent my entire career studying ancient climates and not modern climates is that one of the biggest issues with modern climate change is future uncertainty, right? We don't have a crystal ball. We can't go into the future and tell, policymakers what it's going to be like, but we can use the past to inform the present and the future. And so that's where paleoclimatology really comes into play.
Okay, good. And then could you just give us a brief definition of paleoclimatology?
Yeah, so paleoclimatology is just the study of ancient climates or past climates, and on any sort of time scale, right? It could be 1,000 years ago, or it could be 100,000 years ago. Just study of past climates.
Good. So why is this important?
Yeah, so I'm sure you and a lot of the viewers here are aware that the climate is changing and it has the potential to impact pretty much everyone on this earth, right? And here in Southern California, we definitely feel the brunt of climate change. We have rising sea level. We have really extreme heat waves, droughts, coupled with precipitation patterns that don't really kind of match what we're used to. And as I mentioned, right, one of the issues is that we don't really know what's going to happen. And so scientists rely on paleoclimate data, periods when it may have also been really warm, to inform how organisms may respond today and in the future.
Okay. Now, Megan, to really bring this into a sort of practical world here, can you give an example of how something from thousands of years ago that you've researched equates to today?
Yeah. So I am a paleoclimatologist, as I mentioned, but I study past climates through fossils. Okay. And when most people think about fossils, you think about really large scale skeletons like dinosaurs, things that you see in natural history museums. I love dinosaurs, but the fossils that I look at are much, much different. They are called microfossils. So they're about the size of a grain of sand. Um, they require a microscope for viewing. And actually, most people have encountered microfossils before. When you go to the beach, the sand below your feet contain the shells of once living organisms. So you're actually stepping on thousands of little microfossils. So the fossil group that I study has been around for hundreds of millions of years. And what's really great is that they record the conditions of the ocean water. So they can tell us about the pH, the salinity, the temperature. They can even help us reconstruct sea level thousands to millions of years ago. And so then we can use that information to inform how warming may impact these organisms today and in the future. So that's where we're pulling that old information to today is important.
Good. And can you convey one of the things you've learned?
Oh, yeah. So, you know, I'm working on a topic called hypothermal. So there are these really brief warming events. And we find that these organisms actually change when they build their shells in response to warming. And they also migrate within the water column. So they may actually go deeper to avoid the really warm surface temperatures. And what's really important with these small organisms, right? They're really, really tiny, but they're at the kind of the bottom of the food chain. So they're going to impact the larger critters, the larger organisms that we have in the ocean. Of course, that has a ripple effect.
Good. And then can you elaborate on that ripple effect? Like, what does your research indicate for our future?
Oh, that's a big question. Our world has been around for billions of years, right? And climate change is impacting it in a way that we see the impact every day. And I think the question is, how extreme do we want this impact to be? And it's already causing extreme, issues with organisms building their shells. Oysters, for example, are having much softer shells in response to climate change. And, there are thousands, if not millions of people that rely on seafood, right? So humans are going to be impacted because the organisms in the ocean are also being impacted.
Okay, very good. Now, does your research also have, I don't know, maybe a message that would be construed as positive for the world?
Yeah, I mean, I think we don't have a crystal ball of what's going to happen in the future, but we can make really informed decisions by looking at periods in the past when it has also been very warm. So, I think a lot of people see these projections of future temperature, right? And there's like a range. And you're like, how do we know if it's going to be this warm or this warm? Are scientists kind of just making this up? And no, we're not, right? Those projections are based on paleoclimate data when we know for a fact how organisms have responded to periods of warming. So I guess that's the message, right? Is that when we have these projections, we are basing it on times when Earth has seen really warm periods of warmth as well.
Okay, so does your research suggest to you personally an opportunity that things can be corrected or that we may have gone too far?
Oh yeah, no, I always think that, I'm definitely an optimistic person. And I think, I teach a climate change course and I end it by saying, everyone does what they can do, right? Like I'm not telling everyone to become vegan or everyone start taking the bus, right? Do what you are able to do at this current place in your, in your life, right? So if you're able, take the bus. If you're able, maybe walk to school, but that's not possible for everyone. So do what you can. And I think education is the best way. Talk about climate change with your parents, with your neighbors. And then it just becomes a more common topic.
Thank you very much, Megan. We're going to wrap up here now. This is George Alger signing off for this segment of Our Ventura TV. Until we meet again.